So we are going to have a little bit of a panel discussion. I have with us, I'll let the gentlemen introduce themselves, but this is what we're calling our ROS Industrial End User Panel. So basically the idea here is to talk a little bit about some of the needs and challenges end users have encountered, both in traditional automation and why ROS or the ROS Industrial Initiative is of interest. Right? So in the end, the goal is to take advanced robotics capability built on ROS and have it live and breathe and deliver value in actual factories or out in industrial applications, not just within the four walls, right? So as you hear about later this afternoon. So with that being said, I'm going to allow our panelists to introduce themselves. I'll start immediately to my left. Mitch, you want to introduce yourself to the audience?
Sure. It's a good way to test the mic too, I guess. Make sure it's on. There we go. I'm Mitch Pryor from the University of Texas at Austin. I'm the co-founder of two more applied robotics groups. One is the Nuclear Robotics Group, focusing on putting robots in hazardous environments like nuclear reactors, decommissioning, decontamination, et cetera. The second one is a co-founder of Rapid, which is the rig automation, performance, and drilling industry affiliate program, which focuses on automation in both upstream and midstream applications, all the way down to some refinery and tank inspection. And then the third thing we've recently co-founded is some efforts to support the Army Futures Command with applied robotics, particularly remote vehicles and remote mobile systems.
Great. David?
So I'm David Leeson. I'm VP of Engineering at Glidewell Labs, and we are a large dental manufacturer. We produce 100,000 unique or patient-specific products per week. 100,000 per week, I'll just say it again, because the time, people often don't get that. I'm originally from the automotive industry, and I used to consider myself to be an expert in mass customization in the automotive industry, and then when I got to my current role, I realized I had no idea what I was talking about. Yeah, so we have a lot of unique challenges with that, and look forward to talking to you more about it.
All right. My name is Balandran. I'm the Research and Technology Manager for the Engineer Factory for Spirit AeroSystems. We're a Tier 1, aerostructure supplier, and my main job is to look at leading-edge technologies for our factories to figure out which technology we feel are going to change the way we build our brand new factories for the future.
Right. Well, thank you, everybody. Thanks for those introductions. I guess to kick things off, as David sort of alluded to, right? I mean, let's talk about challenges, right? So David alluded to basically like he had no idea what about mass customization was until his new role. So what have been some of the challenges that you guys have experienced when trying to introduce automation into your organization? David, do you want to?
Sure, I can start for that. So yeah, what we do is so unique that almost no standard solution out there fits for what we need. So examples of that are we have to make all our own CNC milling machines. There isn't something commercially available that makes sense for us to use that, we can, the machines that we build in, the distance between myself and Matt, we could produce maybe 1,200 units a day by machines that we build that take up that space. They're still industrial grade, but we could maybe get one DMG or one HAS in that same footprint. We have to build our own CT scanners because there isn't something commercially available that keeps up with that. So it's just that the driver of making a unique part from very challenging materials, from ceramics, for the most part, that are very fragile to handle. That when it comes to more typical factory automation, all we can really do with that is machine tending. It doesn't really address most of our needs. And another factor there as well is that everything is a unique CAD design. We have our own CAD software, our own CAM software. All of that's hosted in AWS. So every step of the way, we need access to that. We need to communicate with AWS as well. So the old school PLCs that don't really have that connectivity, that's a struggle for us as well. So, yeah.
Well, thanks, David. Greg, do you have any insights there on traditional automation?
Yeah, so for us, we have a lot of legacy programs, airplanes that we've been building for the last 20, 30 years. So what comes with that is we don't have all the CAD models that we need or CAD definitions. So when it comes to automation, essentially we're trying to fit automation in a very manual process, a manufacturing process. And when that happens, I've always told people, when it comes to automation, automation is pretty straightforward and simple if you're structured, you're formatted, and everything else is essentially sequential or follows a set of rules. But when you have a process that has a lot of variations and it can change depending on particular processes or sub-processes, automation can become really complicated. You can automate, but it just becomes more complicated and more costly. And so one of the things that I've seen a lot, prior to my position in management, one of my jobs was to essentially address failed automation projects. So a lot of times when we've had integrators integrate new technologies or new robots into the manufacturing process and things didn't work well, I was called with a team to be able to address them. And so I spent the last 8 years of my career essentially understanding why is it that automation didn't quite meet the demand or the need. And what I realized is there's been a couple of key factors. For us, we get in such a rush to, once we get our technology development, and I love that you guys are keeping track of technology development, but, once we get to a TRL7, TRL8, everybody gets excited. There's a huge hype, and everybody wants to rush it and put it into production. But we didn't realize is we didn't properly mature the technology through the MRL process. We didn't take into account what it's going to take to be able to allow our manufacturing process to be able to mature to that technology. And so by the time we apply it, we essentially see a lot of failures. It was the right technology worked, but it wasn't applied correctly. And I can't tell you how many times I ran into the situation where, I looked really good because I made it work, but it was just really tiny changes in the manufacturing process that we needed to make to make it work, to make that automation piece work.
No, I agree, absolutely. Adaptability of legacy automation solutions to how we manage process variation and the requirements of the process has definitely been a challenge.
And then one thing that I like to know, and this is something that when I was younger, I used to just throw technology out there. I'll do a lot of software development so I can just quickly do a software piece and then put it out there and show people how we could do this. The culture. Understanding the culture of what technology you're putting in this specific culture. If we don't take that into account and we don't build a system to be able to adapt within the culture, they'll spit you right out. And that's something that I've noticed too. That's been a big, big factor for us. Is even though you may have this automation piece work in this work environment, in this workforce, when you start going to another country, to another type of workforce with a different type of union, and try to make the same piece work, and didn't consider how they function and what they're used to, you'll see that it fell.
We used to say we're doing automation to the people as opposed to bringing them along.
A perfect example is Glidewell Labs.
Absolutely. I think it's an interesting segue. So Mitch, I mean, obviously you're not necessarily running a factory, but your team has deployed a number of systems in unique environments, and you work with very unique and challenging situations. Why you obviously take a different approach to how you address your automation challenges? What has been the limitation with historically industrial relevant hardware to what you do?
Well, so there are plenty of robotics problems in the foundational area, and even in just engineering hard, kind of problems that can be solved still at the academic level. When we are funded not by NSF, but by Los Alamos or by an oil and gas company or something like that, then there needs to be that pathway. It can't be an engineer is going to read a paper and all of a sudden become a PhD expert. So ROS Industrial came along at exactly the right time for us to be able to say, look, we've demonstrated this stuff in ROS. Our students have been able to do more because now they can focus not just on that little problem they're solving, but use all of ROS to demonstrate that capability in a relevant environment with all the relevant pieces added. And then we know that because ROS Industrial changes exists, there is a pathway in which it creates an element of trust, an opportunity for training, an opportunity for drivers, for existing systems to exist, to make that path work. That's number one. And even if those companies aren't using ROS Industrial, which many don't, they work with the robotic companies directly and that kind of thing, the second path of which this information gets transferred, of course, is when those graduate students and PhD students actually take jobs at those companies take jobs at those national labs. And when they do, that individual who ends up at a Yaskawa training or an ABB training or something like that is coming in with a much better knowledge than they would get if they got it exclusively from a single vendor teaching them how to use their robotic software.
And that's where I started, right? I started at FANUC training and ABB and Motorman training, right? So I think that's interesting. One of the things that, to come back about the end users and culture adaptation, you shared in a presentation last year, Mitch, I thought was very insightful. That's one of the reasons I asked you to participate in this panel about bringing a system, and you had actually these operators or end users that didn't necessarily interact with automation. What was that experience? How did they adapt or react to the automation?
So the system he's referring to get everybody there is we actually took some robots up to Portsmouth, Ohio. We actually deployed some robots in a large facility, 33 acres under roof, that had originally been used to use a gaseous diffusion process to purify uranium. That is now a very defunct factory. It needs to be taken down. It's got a lot of dangerous gases in it and things like that. And it is currently managed by the United Steelworkers Union. And so when we brought those robots in, there was a top-level DOE risk all the way down that somehow these robots would be taking jobs. But that was not what happened at all. The robots actually being utilized by those individuals created an opportunity for them to see as a tool in a toolbox. Like, oh, this is going to do the boring parts of my work, and I still get to do the interesting parts of my work. Was really useful. And so we were actually invited then to take that to United Steelworkers Union conference in Pittsburgh and demonstrate it there. And that was excellent. And I've got a good example and some pictures of something I did recently, if I'm allowed to show them.
Melissa, can you throw a picture up real quick?
Okay. So I recently had an opportunity to go to the now I'm going to blow the name of it, the Yakima Training Center up in Washington, D.C., in Washington, the state. A general invited us out to watch a joint integrated exercise where robotic and ground vehicles participated in overcoming a breach, which is basically a fortified position that the enemy might have. It's one of the most dangerous things that soldiers can do. These were some breach tanks that were actually running here, and if you move to the next slide, you will see the back of what is actually going on inside the vehicle that's running that tank. And when I walked in there, I laughed because, one, the Xbox controllers is a 19-year-old private who's running this giant robot using the thing that he had learned. But then I looked behind him and I saw that terminal window. And if you go to the next slide, these are the lines that were right below that terminal window that to run that tank, that soldier was typing onto a tap screen to run it, ROS launch. And I laughed, and the four-star general, what are you laughing about? And I turned to the private who was typing that stuff in, and I said, are you comfortable with this? And he said, this is great. You know, I've been out here for a week playing with this. The people at the Grant NGSC, the science center that was developing this stuff, basically TARDEC, for those of you who aren't keeping up with all the acronym changes, got a little scared. But then when the pirate said, oh, you know, they've taught me some of the flags, got pretty good at typing it, I now understand what some of the different things mean. And this really let me know that if they're comfortable with this level of interaction with ROS at that level, then it allows us to deploy and try new things faster without having to put a giant polished shell on every new thing that we're going to put out there for people to try. So I saw this as a really exciting opportunity, and I just wanted to share the story with you guys.
I appreciate that, Mitch, and I want to come back a little bit, follow up on what Greg indicated about like where we don't want people to feel like automation is being done to them, right? So either have them as be part of the loop, or when they can richly interact with systems, or sometimes we assume that like the command line is just unattainable, right? So in certain cases, if we want to iterate quicker, and depending who our collaboration partners are, to Mitch's point, maybe we can iterate faster and engage a certain subset of our folks on the floor. No, that's very interesting. So I guess I'm going to pivot a little bit. So we've talked a little bit about the challenges of leveraging traditional automation. Mitch segued a little bit about folks who are applying ROS. So what about either ROS, or what about the aspects or elements of, as you observed, made ROS beneficial for as you consider automation and you're moving forward? David?
Can I just take a tiny moment just to pick up on both those points there? And actually, I think you in that A3 presentation, you really made those points very well, and that is that I don't think people aren't scared of having their jobs replaced by automation if they see growth in the company, and if they trust in the culture of the company that they'll be repurposed and retasked. And you know, we've had to go through that a number of different ways, and I think there is now that faith that there'll always be a place for them, but they need to know that the threat is if we don't do this, if the organization does not do this, then your business is going to get offshored, and then it's guaranteed you'll be out of a job. So
no, that's fair.
And that's a hard reality to get across, I think, sometimes. But anyway, sorry. So your question
like
about
relative to following on about traditional automation and the challenges. What about ROS seemed appealing to you when you think about the challenges of introducing automation into your product, in your organization?
Yeah. So really we've got to the point in what we're automating where we've reached the limits of what we can do with conventional automation. All the machine tending projects, all of those more straightforward projects have been done, and everything that we've done past that point has been some kind of custom tool that we've created. There's a challenging interface there that has some robustness and reliability issues, and with unlike making a product to stock, there's never any buffer between us and the customer. So if something goes wrong, if we have a problem, there's always a customer waiting, and it can snowball into a very big problem very quickly. So we don't want to create another custom solution for that. We don't want to do something development. We want to be able to benefit from the investment of all the people in this room and all those organizations that are putting into a platform that we can use. And so then the next step in our journey in automation is really being able to manipulate the product directly. And so we need to scan and register and acquire a tooth, or any potential tooth of arbitrary complexity. And so really we see ROS as the only pathway to that. So it's kind of an easy decision-making process from that point of view, because we're evaluating our own custom solution against something that is supported by an entire industry.
No, the use case is very challenging, right? We think about velocity, high precision, yet lot size of one, right?
Yeah.
Right? So it brings all those things to bear. So, Greg, when you think about your experience, both from when you were deploying traditional automation and now looking at what made ROS appealing to you and your team and your organization?
I think for me it was pretty simple on making the choice with ROS. It was not simple to convince my leadership of going with ROS, but when I look at my team, especially my old team with the automation robotics team, what is it you're trying to actually research? What are you doing for research and technology and robots? For one piece of airplane, we drill 450,000 holes so we can put fasteners inside of it. And so when it comes to technology, we've done a lot of investments and work with a lot of integrators to do a lot of the, big machines to drill the holes and insert the fasteners. And I told myself, that's why do research in that? Why reinvent the wheel? There's already many people in the game, and there's a lot of great companies out there that are doing a fantastic job. So when it comes to research and technology, we needed to tackle the areas where automation was not being implemented. We needed to tackle the areas where those integrators weren't comfortable getting their feet dirty, right? And so once you start looking at those applications, you start realizing why is it that they're not doing it? And most of the time it's because there's an art behind what the manual workforce is doing. Mm-hmm. There's not a straightforward solution for a typical robotic application or machine application. There's, as an example, for us, sealing, as an example. Sealing is a perfect application that you think, hey, that's pretty easy, right? You see a guy doing it out there, and he just squeezes sealing and then puts it on the part, and he's done. And he does it really, really fast. But what you don't know is that he's got years and years and years of experience. And he's actually meeting a pretty tight tolerance that when he applies the sealing, that it's a visual aspect also, but also there's a tolerance and a visual aspect to that job. So when you try to make a robot do that, it becomes really, really hard because you have part variation, you have viscosity variation, and so it becomes really complicated. So for me, back to your question, ROS became an easy tool for us because of the rapid prototyping, being able to communicate with robots right away, being able to integrate sensors. So for me, it was the sensors. I plug in a sensor, and automatically within a few minutes, I can get the data and visualize it. Mm-hmm. because it's not just about communicating with the sensor, but also creating a visualization within ROS. And to me, that's what was really appeasing, because a lot of the other software that you get doesn't do that, and you pay a lot of money for it. So the other aspect was it was free. But again, I mean, for us, it all started with rapid prototyping, trying to figure out what we can do with these areas that weren't technology friendly or automation friendly. And then once we started gaining some ground there, well, then we started realizing, man, maybe we can put this into production. And what would it take to harden it?
Well, that's the next question, right? That's the
Yep.
next step.
That was an alley-oop for you.
Right. So, obviously, Mitch, your team, you mentioned some critical environments you've had to go into and harden. I mean, how do you feel the trajectory of, like, say, the development of the framework itself has been relative to some of the use cases you're trying to address through your program?
I think the framework is progressing pretty well, and the good news is I think that upper management in these areas is starting to understand the importance of developing that framework first, as opposed to developing the robots that will actually be deployed. I think there was a lot of work. Oil and gas is a good example where a lot of the people would go back and say, we're going to automate this stuff, and upper management's first question correctly was, will this be Div 1 Class 1? Will this be explosion-proof? Can I put this in my facilities? And a lot of people spent a lot of money, engineering money, to develop these systems that then ended up being very proprietary, not very useful, not very adaptable, and I think that inhibited some of their long-term deployment. Whereas some other companies, including some members of this ROS Industrial, have said, look, we're just going to get hot work permits. Let's go out, let's play with these robots, let's learn what's easy, let's learn what's hard, and let's develop the framework that's going to get these things used. And once we have a system that our workers see as being beneficial, then we'll put in the engineering effort to make sure that it is compliant. We've
seen definitely a tipping point there where, everyone asks, like, oh, can that go in a paint booth? Can that go in this certain environment? And then, so they spend all that engineering up front, but then, like, obviously the capability isn't there, right? So I think that's an interesting point. So obviously you guys all have various levels. I mean, your team's experience so far is just getting going on your ROS journey at Glidewell. But I guess, Greg, I'll put you on the spot. I mean, you guys have a little bit more experience. Where have you found some challenges in trying to incorporate ROS in your solutions?
For us, I'm going to share this story later on, but we've had some really good successes at implementing ROS in production and leveraging it to essentially provide savings for our company. But where it's been hard, and as I mentioned before, the Material 9 was great. MRL was pretty good as well. But when it came to maintainability, sustainability, so our maintenance group didn't know how to interface with our ROS computer. We decided it was going to be a black box. Once it was a black box, then IT said, well, you're not connecting that to our network. So they said, okay, well, it's going to be an isolated network. So now it's going to be on an island, right? And it's going to do all this cool stuff, and it's going to do all this automatic pathfinding for you. Then ROS distribution came out, or a new Ubuntu, and now we need to upgrade our systems. And that became a pain in the butt for us. And one thing that I noticed is when we start putting things in production, because we didn't have the right type of tools, and that's something I'm going to speak to you about, of being able to provide more of a diagnostic tools for maintenance groups to be able to troubleshoot your systems. In order for them to troubleshoot or try to get the system up and going when things didn't go quite right, they will have to then call us in R&D. And if we're supporting production, then what are we not doing? More R&D, right? And so that's kind of the maintainability of ROS and being able to have the maintenance group being able to support it.
Absolutely.
It's been very difficult.
We tend to coin that, like where I came from in our operational environment, is sustainability. And that was something that we took for granted. Mm-hmm. So to your point, right, we could go through and do a big FAT, follow on with an SAT, but at some point, right, something changes, right? A maintenance group is like, hey, the system's not performing right. All of a sudden they encounter, we did the same thing, the black box, and everything just falls apart. Next thing you know, I'm flying somewhere with my USB stick. No, that's obviously not. So sustainability is definitely something we're interested in as well. I guess right now, that's my canned question period. I'd like to turn it over to everyone in the floor here, and potentially I see there's the chat light on, but I don't know if anyone's monitoring the chat. I don't have it in front of me. But are there any questions here in the room, right, for our end users? People are trying to deploy it in operation.
Say that we're using.
It's an easy crowd. Oh, wait, here we go. Oh.
There wasn't a question.
Oh, okay. Thank you for checking. So I guess I can go like one step further, right? So David, I'm going to pick on you a little bit because it's something you said when we were just chatting before this panel about not really just thinking just about the robot, right? So when you think about and see some of these things going on in the ROS community, what are some other things as you think about your upcoming challenges that maybe we can address with ROS?
Yeah, so you know, a common struggle for us and common pain point for us has been always in the interface between systems. So we're trying to unify that as much as possible, and we've already made strides to do that. So, for example, the same controller that runs our CNC machines, that runs our custom machines, is now also running our robots. We've made some changes there. And we see that broad potential in ROS, and we would like to see us to go really to component level with ROS. And it could be, you know, running our entire line, our entire factory. There's no reason it shouldn't be used for custom machines the same as robots, and all the same benefits are there. And I don't remember who it was I think it was an Intel gentleman on the panel yesterday talked about, you know, and the maintenance concerns you're talking about, that you have, you know, a legacy application, a robot you don't buy anymore, you've moved on from, and there's a problem with that, or a modification needs to be made, and you don't employ anyone who has that skill anymore. So having a single platform and a single knowledge base that is universally applicable across the factory floor would really be a big benefit for us.
No, absolutely. You know, and actually you saw two examples in the other locations updates between RMF. The RMF initiative is looking at multi-vendor support all the way up to the ERP, MRP interfaces, and then of course Scalable was a similar vein. And our partners over at the ARM Institute are funding initiatives around this notion of interoperability. One of our very first ROS projects in my prior role was an interoperability. Can I share information between disparate devices? And actually that's where ROS somewhat got its start, right? We had all these cool sensors and different applications. And obviously that's some of the work you've done in your team, Mitch. I mean, it's circling back to a little bit like some of the work you've done, right? I mean, are you leveraging ROS beyond just like, say, making robots move for your applications?
Absolutely. I mean, a lot of my, and this is where I think a big push into getting postdocs out of these roles and more into undergrads. I employ 6 or 7 undergrads, and primarily what they do is sensor integration. There's this industrial fugitive emission sensor, and I need a ROS node that takes that data and pushes it back out. And thanks to things like ROS Serial, ROS, all the ones that interface with the standards, whose names I don't remember, don't really care about, we usually are able to get those nodes set up. So a lot of the peripheral devices we have are the sensors that people wouldn't necessarily have previously thought about being a part of ROS. And radiation sensors, lanthanum bromide sensors, fugitive emission sensors, anemometers, that kind of thing. Oh, absolutely.
I do catch a question. I see it's highlighted. Haish from the Netherlands has asked about hardening. When we talk about hardening, is someone willing to elaborate when we talk about hardening of like, say, the ROS application or the specific ROS components? Greg, do you want to?
Yeah, for me, what I mean by hardening is, number one, when the error handling is huge for me. So when the system works fantastic, everything works correctly, then it's pretty straightforward that your solution works. But, you know, and I always bring this back to an example. So a couple of years ago, I'm going to go back. A couple of years ago, we decided to do this technology development. We used a ROS application, and it took us roughly about a year to go from Chero nothing to Chero 7, and which is pretty fast, right? But in order to harden it, to get it from a 7 to 9 to then implementation and then to sustainability and maintainability, it took us about a year and a half after that. And so what is it that I mean by hardening? Is it took me just as long or longer to harden the cell. And what that means is you have to make it error prone. You have to be able to react. You have to understand the type of things that are going to happen that is unexpected, and then handle them correctly, and then properly communicate that to your operator or user. Mm-hmm. And then for a lot of our solutions in the future now, they have to be able to connect to our systems.
Yeah.
Where in the engineering factory for for all the automation that we're looking for the future, we have to be able to connect to our main system. And for us, Hardening would be also hardening your computer, making sure that you come up with a standard, something that's a little bit more robust, embedded. But I mean, for us on the hardening side, it's basically diagnostic tools and how our operators are going to maintain it. They're not ROS experts.
Yep. And then I believe Annabelle, if I'm correct, is with AWS. She's inquiring about what tools and processes are used for simulation and deployment of applications. You mentioned visualization. Obviously, RViz comes to mind, and folks tend to mention Gazebo. I mean, are you leveraging a lot of those tools in your application development? I mean, I know your team just recently is getting on board or familiar with Gazebo, David. I mean, is that something you guys are considering?
Yeah, it absolutely is. I mean, I think there's a lot of time compression that we can leverage by doing that. You know, so we've got the benefit of 8 million plus designs in the cloud that we can experiment with, and we have all the CAD data for that. Mm-hmm. So I think that can save us a lot of time. But with what we do, there's always a new edge case every day. So there's definitely going to be limitations in simulation, and so we need to think about, in terms of, again, the robustness of the application, what do we do when it goes wrong, and what's our workaround?
Absolutely. Simulation been a key tool for your team, Greg?
It has, especially for us on the rapid R&D development. What's been key for us is to do quick simulations, especially just on the restudy analysis, right? So what's the first thing that you consider when you consider a robot application? The first thing you want to know is what type of robot do you need to pick. And so to be able to and we do have offline programming tools, but only a few know how to use them. And so for me, being able to tap into the ROS capabilities and just do that extremely fast has been key for us. And I'd like to tap into what you were saying about using ROS beyond robots. So we're also seeing huge potentials of just taking advantage of the sensor agnostic part and being able to just communicate with sensors, grab that data, process it, and then react to certain situations without robot applications. And we're seeing a huge benefit from that.
I mean, I'm sure, Mitch, you encounter it too, because a lot of these, you mentioned hot environments. Obviously, simulation becomes key, right? You need to do as much testing before you throw something into the hot environment. Obviously, you test in iron as well, so to speak. But
yes and no. On the one hand, our job is to teach these students up. One student, Adam, in the room, beat his head against Gazebo with a new robot we were trying to build a controller with for 3 or 4 months before we realized let's just wait till we get the hardware and play with it because of the physics and that kind of stuff that's kind of working. And also you want a lot of these students kind of understand how to actually build and get all that thing going. So we don't do as much in simulation. Where it is starting to come into play more is we're working with Applied Research Labs. We're building a campus-wide simulation in Unity so that we can start to take some of the long-term autonomy out and do some broader scope stuff like that. Feature extraction from large spaces, which is something that is much more difficult to do.
No, feature extraction is a hot space.
Yeah, in real life. So that's a couple of the different spaces we are. We do try to use it some, but there's nothing more satisfying than seeing a robot move.
No, absolutely. Yeah. I guess Haish had a follow-up question. He was curious, Greg, when you talked about hardening, if any of those things are really specific to ROS, or if it's really just custom software development, right? Or is there anything specific to ROS relative to the hardening aspect?
A lot of it is just your pure automation hardening.
Yeah.
I mean, but a technology that I'm going to talk about today is going to be our scan and plan technology. So we actually were able to put that in production. And when it came to hardening, because of the nature of scan and plan, you're essentially creating a brand new NC tape every single time, right? So it was a technology that we implemented, and because of the nature of the tools and things weren't going to always be in the same place, we needed to scan it every single time and then perform a job. Well, typically for what we do is once you release, an NC programmer releases an NC tape, that's it. You don't change it, and you lock it. But this situation, we were essentially creating a brand new NC tape every single time. And so by hardening is we need to develop the right algorithms with the ROS to be able to handle multiple situations. And as you can imagine, If you have a single part, so this is running several parts. For a single part, you can have a magnitude of different variations of the same part. So when you run that simulation, it can work fantastic about 90% of the time, but 90% of the time it's not good enough. And so hardening is essentially collecting those ROS bags, collecting a huge data set of everything that goes your way.
So in certain cases, ROS provided some tools to actually enable hardening.
It enabled it as well.
Yeah. No, that's a great point. You know, I want to come full circle. You know, one of the things when I thought about the hardening aspect, is it specific to ROS? I think what's specific to ROS, and it was the same with my team when we were trying to deploy into factories, is we cut our teeth on FANUC, on ABB, you know, leveraging offline tools that are kind of commercially available. It was the first time we'd ever actually tried to really write software that ran in a factory, right? So we had to grow those skills. Yeah, the hardening was difficult because we were kind of bootstrapping the idea of like actually writing code, right, in that context, right? So, you know, obviously it circles back to the talent pipeline, right, and the scalability of our training, and how do we address the manufacturing needs, like for organizations like yours, David, that are kind of growing that capability relative to, and it's great that you mentioned undergrads too. I mean, we're excited to see ROS development seep lower into the educational pipeline. I mean, have you seen that progressing?
Yeah, so back to the simulation reality thing, just to make one last note, I want to make sure we don't make a false dichotomy there. There's a lot of augmented reality, move it, stuff, you know, please plan, please move, like the integration of that simulation in real time with the actual moving of the hardware.
No, and that's obviously was appeal to our team as well.
I gave a talk at the External Advisory Committee for Computer Science at UT about a month and a half ago, and a particular company came up and talked about how, with the robotics and things like that, that there was, when are we going to be able to hire someone with a bachelor's that can do this stuff, as opposed to a bachelor's of science? And I do think that a lot of the people who manage curriculums at universities are going to be slow to change and modify. So without you guys letting them know where you heard this from, I would encourage all of you to try to get on the external advisory committees at various universities and community colleges in your spaces and make sure that they understand the need. And take the message that this is not about learning ROS as a MATLAB technical piece of software that you're learning to use, but that there's actual foundational understandings of kinematics, dynamics, representations that go into that are actually core to education as well as to the success of our industry.
I think that's a great point. You know, we've been very excited about some of the developments. One of the things that was percolating when I was still in industry was the notion of like, oh, let's come up with a more advanced robotics technician program, getting to your point about maintainability, sustainability, right? And then I was like, hey, at some point, do we need, for robotic technicians, which is in a lot of cases a 2-year program, do they need to start getting at least like to your point, a troubleshooting crash course or something to be able to do a couple command line queries? I think that's an interesting thing, and yeah, participating in EAC is a really great thing. I mean, do you guys have any? I mean, what are you guys doing to address the sort of the talent pipeline? Is this something you're actively thinking about in your organization?
So yeah, very very much so, and we're doing some of what you suggest with our local university, UCI. And so a sneaky thing we did as part of our training event, we actually used that to bring promising students over, opened it up to academic staff. So we're trying to pull them into it as well. And yeah, I think just it's a temporary situation we're in because we, aside from those core skills you mentioned, there's just all that application knowledge which comes is hard earned for the most part, through bitter experience, and so the folks that have that, they typically struggle with, being a software developer, right? It's not what their experience is fit to. So we need a way to kind of, bring those people together, have good collaboration with them, fuse some of those skills, and, something that, I really was pleased to see yesterday was the gentleman from Microsoft, I think it was Lou, is that his name? Because the thing that all of, that kind of typical profile of someone working in automation today, they know proprietary robot interfaces, they know PLCs, and most of them are really comfortable with Visual Studio, right? It's the one IDE that they use every day. So if ROS can can work a little bit more effectively in Visual Studio, it can help bridge that kind of skills gap.
Absolutely.
Yeah.
And Greg, in talent pipe. Oh, Phil, you have a comment, question? Phil Freeman, he's just following.
So the one thing I've kind of noticed in this conversation is we're still seeing a lot of activity in ROS where the end user is the core developer, right? That the people who are going to be using and deploying are building up the talent within their corporation to go use ROS. And the question I have in my mind is, are we seeing any momentum? Are we starting to see evidence of an integrator community growing that, you know, is committed to ROS and is trying to develop these advanced applications for other companies? You know, we went to +1 yesterday. That was really impressive, right? But really novel too at the same time. So do we see a trend in that direction? I don't know. From the end user's perspective, are you finding more companies that are coming to you saying, yeah, we can help you solve your problems and we can do it with ROS?
I mean, obviously, we do get inquiries from integrators, right? So we are now at a tipping point, and maybe Alex, via his organization, is getting inquiries from his membership relative to, like, what is this ROS thing? And that's where it starts. Obviously, it comes from the end users, right? Asking these questions like, hey, why aren't you leveraging these tools? Is something really broken here? I mean, one thing to say, I just don't want to use this, it's a university thing, but if you really poked around at it. So the good news is we had a number of integrators reach out about actually participating in this actual event here. I don't know, we had so many cancellations, I've lost a little track of who actually made it, I apologize, but that was encouraging, right? There was at least 8 integrators that inquired about coming, right? And so, and BW Designs was here yesterday, they actually do integration as well. So we are seeing a little bit more engagement, maybe the ARM Institute as well is getting engagement from the integrator community. And it's obviously something we talk about in that community as well, is like, hey, they deploy the solutions, how do we bring them along, right? And so absolutely, it's a key motive. I don't know if you guys have had similar experiences with the integrator community.
Yeah, I mean, I think for me, so we've been playing around with ROS for about 8 years now, right? And I'm just now trying to come out of the shadows, okay? You know, and the reason why I say it like that, Phil, is because yes, we have approached integrators and have mentioned it to them in the past. Hey, have you ever played around with ROS? This could really solve your issue you're having. And they say, ROS who, right? They don't understand it. And that was a couple of years ago when we approached them. It looks like there seems to be a change coming up. However, my dilemma is being in the research and technology group, as we're developing these unique capabilities internally using the community, it becomes very custom application that solves really key issues for us that then becomes a high level of IP. And so for us to be able to release that to an integrator who then potentially could use it somewhere else, then the fear is, do we lose competitive advantage? And so that's the part that I haven't figured out all the way yet. You know, I've told Paul when Paul was here in ROS, you know, and I told Matt, there's so many things that I want to share. I want to give back to the community, but because of the industry that we're in, I can't quite do that.
And I imagine a lot of organizations struggle. So the panelists will be here. A lot of them will be here for the rest of the day. I know, Mitch, you have to actually teach a course this afternoon. But I appreciate the time. We've got to pivot. Catherine is up next. So panel, thank you. And thank you for those online. Thank you for the questions from the audience.